Hello students, let us do this classwork. Okay, so here if you see on the right side, I have two classes. The first one is public class Naruto, in which I have two functions. The first one is a static function whose name is family name. The second function is a non-static function. Okay, so this is the class Naruto. Now we have another public class called Boruto, okay, which extends Naruto. Similar to the parent class Naruto, Boruto also has one static function and another non-static function. Now if we look at the left hand side, okay, we have a class called public class learning, where we will see how the polymorphism works. So here we have the public static void main function, in which we are performing the following tasks. First, we are creating a Naruto object for the class Naruto in the first line. In the second line, we are creating the object for Boruto and assigning it to the class Naruto. Okay, so this is a mixed one. The next one is we are creating the object for Boruto and assigning it to the Boruto object. Now, what happens when I execute these lines? Okay, you have to look at every line and print the output. What would be the output for each of them? For example, when I execute nar1 dot family name, what will be the output? Will it be Uzumaki or Uzumaki Hyuga? Okay. Similarly, if I execute the next line, nar1 dot ability, what would be the output? Is it Rasengan or Lightning Rasengan? Similarly, for nar2 dot family name, what would be the output? For ability function, if we call, what is the output? Like this, you have to write the output of each of these functions. Please pause this video for 5 minutes and try to look at this example and try to write the output. Please think carefully when you are writing the output. Okay, you have to understand how the static works. I hope all of you have written the answers. Now we will look at how to derive the answers to the functions. Okay, handling static methods is a very tricky solution in dynamic programming. So to solve it, I have come up with the new method to understand how the dynamic binding works. What you have to do is, when the objects are being created, use this logic. Okay, once you create a logic, check whether the left hand side class name and the right hand class name are same or not. If they are same, you can think of it as a pure object because LHS and the RHS are the same. So you think of a pure object and simply follow the basic binding practices. Okay, there is no binding that happens between parent and child. So simply call the respective class function and complete it. If you notice that the LHS and RHS are different, that means you are creating the object for a child class and assigning it to a parent, then you think of it as an impure object and we have to perform dynamic binding. So when you are doing dynamic binding, you have to check the method. If the method is a static method, okay, go to the function that belongs to the RHS class. Okay, if the method is static, you have to go to the method of the right hand side, that is parents method you have to call. If the method is non-static, then you have to execute the child's method. Okay, so this is the logic gates or the circuit that you have to execute. Let us see how this logic gate is helpful for you. Okay, so coming back to the assignment. Okay, please observe that NAR1, LHS and RHS are same. So this is a pure object. NAR2, the LHS class and the RHS class are different. So what Java is going to do here is, it is going to create Boruto object and going to put it in the Naruto class. Okay, that is assigning to the Naruto class. So this is impure. LHS is not equivalent to impure. Next, Boruto, and on the right side and left side the same. So it is pure object. Okay, so this we know. Okay, the same thing you can do it here. Now here we are just creating the objects. Okay, so here it comes, since it is Naruto, the compiler, let me use the drawing pencil. Okay, it is compiler, it comes to Naruto class. Since there is no constructor here, it simply goes back to Boruto. Okay, now because we are saying no Boruto, the compiler will come to Boruto, extends Naruto. So it comes here, and since there is nothing inside, there is no constructor for Naruto class, it comes down, okay, to Boruto. For Boruto class also, there is no constructor or global variables. So it simply goes and do the third line. Here we are creating the, okay, sorry, before going, this object will be assigned to Naruto class. Next, we are creating the same object similarly for Boruto, and we are creating. So this is the pure object. Now, once this is done, okay, the compiler comes to here. Okay. Now let me clear all the ink. Okay. So let us redo the compile. Now let us use this line. NAR1 comes here. Okay. So for NAR1, the LHS and the RHS are the same. Okay. So this is a pure object. So when I say family name, okay, the compiler goes here, since it is a pure object, it goes to family name Prince Uzumaki and exits. Okay, and once it is done, the compiler comes to the second line, nar1 dot ability. Okay, so again the compiler goes to here. Okay, for nar1 it is a pure object, that is LHS is equivalent to RHS. So we have to simply go to the pure object, how it behaves. It goes to the Narthos class, okay, goes into ability, prints Rasengan, and then comes out. And then it will come to this line, nar2 dot family name. Here the things become different. Okay, so I will remove and then we will come here. Okay, here we will check LHS is equivalent to RHS. No, LHS is not equivalent to RHS. So let's go up. Okay, so this is our impure object. Now check the binding. Is family name function static method or not? Okay, please check. Family name is a static method. Okay, yes. So what we are going to do is we have to go to left hand side method. So what is on the left hand side? It is Naruto. So the compiler, what it will do? It will go to the function of family name here, Prince Uzumaki, okay, and then comes out. Understood? Now we come to Naruto dot ability. How this will work? Same way. Let me erase it. Let us bring the compiler logic here. Check LHS equivalent to RHS. No. So we will do dynamic binding. You come here. Now check this function. Is it a static function or not a static function? Here ability is not a static function. Here also ability is not a static function. So it is no. So what we have to do is we have to go to RHS method and complete it. So what is the right hand side class? Right hand class is Boruto. So you enter into Boruto class, run the code for ability, print the output as lightning Rasengan. Okay. For static class, we went to Uzumaki. For non-static, you see, we are going. So this is the logic. So always keep this logic in mind and then come out. Now, if you look at the object bore1, it is a pure object. Okay. So simply it will go to Naruto. It will go to the family name in the Boruto class. Prince Uzumaki Hyuga comes out. Next, it will check at Boruto.ability line. Since it is the pure object, it will behave similarly. Goes into the Boruto class, enters into the function ability, prints lightning Rasengan, comes here, finishes and end. So this is how the program will behave. So for the first line, the output is going to be Uzumaki. For the second line, the output is going to be Rasengan. For the second one, since it is the static method, okay, we have to go to left hand side. So we will go and print Uzumaki. For non-static method like ability, we go to child and we will print here. So here it varies, okay? In the dynamic binding, it varies here, okay? Here for both it is a pure object, so it simply goes to Bordo class and prints Uzumaki Hyuga. For ability, it goes into the ability function and prints lightning Rasengan. So this is how it happens. So no matter how difficult the program looks, you always apply this logic on the on the lines or on the objects and see which functions you are trying to call. This way you can complete any code. Okay, hope my explanation was helpful for you. If not, please try to watch it again and try to learn. That's all. Thank you.